Right now, on an island most people couldn't find on a map, engineers are standing in front of a water treatment station that no longer exists. Power poles across an entire island chain are lying flat, snapped at the base like they were made of matchsticks. 2,000 kilometers away, meteorologists are staring at satellite loops of a storm so large it doesn't fit on a single screen without zooming out, and it is still not finished. This is Super Typhoon Bavi. It hit peak intensity at 180 miles an hour. It was closing in on the theoretical maximum strength a storm can physically reach on this planet, a ceiling almost no tropical cyclone ever touches. Then, instead of weakening the way storms are supposed to, it grew. Not stronger, bigger. Its wind field expanded so violently that meteorologists ran out of normal vocabulary and started calling it gargantuan, a storm now ranked in the top 3% of every Western Pacific typhoon in the last decade. And here's the part that should actually worry you. This isn't a freak event. It's the third Category 5 storm to form on this planet in 2026 alone, and the year isn't even at its halfway point for typhoon season. Today we're breaking down exactly what happened, why the forecast models kept getting it wrong, and what's already forming behind it. No hype, just what's in the data. Drop a comment right now. Have you ever been inside a typhoon or hurricane warning zone? Tell me where and what the waiting felt like, because that waiting is a bigger part of this story than people think. If you want to know the moment the next one starts spinning up, subscribe, it's free, and I only cover the storms that actually matter. Let's get into it. Part 1: The storm that shouldn't have been possible this early. In early July, a disturbance east of Guam did something meteorologists watch for and dread in equal measure. It found perfect conditions and used every single one of them, one after another, with almost nothing standing in its way. Start with the water. Sea surface temperatures in that stretch of ocean were sitting around 30 degrees Celsius, roughly 86 degrees Fahrenheit. On its own, that's warm but not unheard of. What made it dangerous was depth. Storms don't just need warm water at the surface, they need a deep reservoir of it, because as a typhoon spins, its own winds churn the ocean and drag cooler water up from below, a self-limiting mechanism most storms unknowingly trigger against themselves. Meteorologists measure this as ocean heat content, and in Bavi's path it was measured at over 110 kilojoules per square centimeter. That number meant the warm layer went down far enough that Bavi never triggered its own brakes. It had, effectively, an unlimited fuel tank sitting beneath it the entire time it needed to intensify. Now layer wind shear on top of that, the crosswinds at different altitudes in the atmosphere that tear a developing storm structure apart before it can organize into something dangerous. Over Bavi's formation zone, shear was measured at a mere 5 to 10 knots. For a storm trying to build itself, that's close to silence. No shear ripping at the top of the storm, an endless column of warm fuel underneath. Bavi became a tropical storm on July 1st. Within 2 days it was a typhoon. Hours after that, a super typhoon. That is not a normal intensification curve. Meteorologists call this rapid intensification, and it's one of the hardest things in the entire field to forecast accurately, because it requires almost everything to align at once, and Bavi hit that alignment perfectly. Here's the open question I want to plant right now, because it matters more than the wind speed number everyone fixates on. This is exactly the kind of storm scientists say we should expect more of as El Niño strengthens this year. And El Niño is very much strengthening. We'll come back to why that single climate pattern should change how you think about the entire rest of this season. But first, you need to see what Bavi actually did when it reached land, because the story on the ground was almost unbelievable given how early in the season this happened. Part 2: Rota. Bavi made landfall, or more precisely, passed its eye directly over the island of Rota, part of the U.S. Commonwealth of the Northern Mariana Islands, at peak intensity. Sustained winds near 180 miles an hour, a central pressure around 910 millibars. To put that pressure number in perspective, the lower it drops, the more violently the atmosphere is trying to equalize itself around the storm's core, and 910 millibars sits deep into the range where structures aren't just damaged, they're erased down to their foundations. This was, according to meteorological records, the first time a Category 5 storm's eye has passed directly over Rota. A Category 4 storm did back in 1967. Nothing at this intensity ever had. Gusts of 111 miles an hour were clocked at the airport in nearby Saipan. The same reading recorded independently at Guam's own airport, which also set a new daily rainfall record of over 12 inches in a single day. A water distribution station near Rota's airport was structurally damaged, cutting off part of the island's ability to move clean water. Power poles were downed and bent. Not just knocked over, bent, which tells you something about the force involved, because utility poles are engineered to survive most storms by flexing, not folding in on themselves. And this is where the story does something most disaster videos skip past entirely. Nobody died on Guam or the Northern Marianas. 0 fatalities reported, despite winds that rival the strongest storms ever recorded making landfall on U.S. territory. That's not luck. That's warning systems, staffed evacuation shelters, and a population that has lived through this before, all actually working the way they were designed to work under maximum pressure. Keep that detail in your pocket, it's going to matter again later, because it's the quiet flip side of every record-breaking number in this video, and it's the piece almost nobody talks about after the headlines move on. But Bavi wasn't finished. It was already moving on, and the next phase of the storm is arguably the strangest part of this entire event. Part 3: the storm gets bigger, not smaller. Here's the part that broke the pattern forecasters expected. After slamming into the Marianas, typhoons typically start to weaken. They've dumped enormous energy into the ocean. Land friction has begun grinding down their structure. The easy, uninterrupted part of their life cycle is over. Bavi did something else entirely. It underwent what meteorologists call an eye-wall replacement cycle, a process where an outer ring of thunderstorms strengthens around the original eye and effectively strangles it, replacing the old eye wall with a new, wider one. Normally, this is a storm's way of resetting itself, and it often causes temporary weakening before a possible second round of intensification. For Bavi, the outcome looked different. Its wind field, not its peak wind speed, but the sheer geographic footprint of damaging winds radiating outward from the center exploded. Tropical storm-force winds extended across 10 full degrees of longitude, an almost absurd span for a single system. Hurricane-force winds stretched across a band nearly 400 nautical miles wide. Waves generated near the storm center were estimated at up to 80 feet, tall enough to be picked up on offshore wave buoys hundreds of miles from land. This is the storm meteorologists started calling gargantuan, not because it produced the highest wind speed ever recorded, but because its sheer physical size put it in the top 3% of every Western Pacific typhoon tracked over the last 10 years. Size, more than peak intensity, is often what determines how much total damage and flooding a storm inflicts, because a bigger wind field means more coastline exposed to dangerous conditions for longer. And here's the detail that should genuinely unsettle you, if you think about where forecasting is heading. Roughly 60% of Google DeepMind's machine learning-based forecast ensemble had, days in advance, predicted Bavi's winds would top 180 miles an hour, a forecast that turned out to be essentially dead on, while some traditional dynamical models lagged behind in catching the storm's full intensity. We are entering an era where AI weather models are starting to outpredict systems meteorologists have relied on for decades, and Bavi became one of the clearest real-world tests of that shift so far this year. That's not a small story hiding inside a bigger one. That might end up being the bigger story. So the storm that broke a landfall record also quietly broke a forecasting narrative. 2 loops open at once. Let's close the first one. Part 4: 2 million people, 1 decision window. As Bavi tracked west-northwest, curving on a path that carried it past Taiwan's northern edge and Japan's Ryukyu Islands before driving into mainland China near Shanghai, the storm began losing raw wind speed. Cooler waters and rising shear finally started doing their job, dragging it down from super typhoon strength toward something closer to a strong tropical storm. But size doesn't disappear at the same rate wind speed does. What arrived in China wasn't a storm anymore in the way people picture a typhoon. It was a slow-moving, enormous rain and surge engine dragging a wind field wider than most countries are across. Nearly 2 million people were forced to evacuate across the storm's Chinese landfall zone. Not evacuated because officials were being overly cautious, evacuated because a storm system that size, even weakened to tropical storm equivalent winds, was still fully capable of dumping catastrophic rainfall and pushing dangerous storm surge into low-lying coastal cities. This is the part people consistently underestimate about big typhoons. The wind speed number on the news ticker is often the least dangerous statistic in the entire event. Flooding and surge, driven far more by a storm size and forward speed than by its peak winds, are what actually kill people in the days after landfall, long after the Category 5 headline has stopped trending and the cameras have moved somewhere else. This is Bavi's second appearance in the Marianas region within 3 months. Category 4 Super Typhoon Sinlaku hit the same general area back in April, killing 17 people and causing roughly $1.5 billion in damage across the islands. Two catastrophic typhoons, the same corner of the Pacific, 90 days apart. Zoom out further and the pattern gets sharper. Sinlaku was counted as the 10th Category 4 or 5 tropical cyclone to strike a U.S. state or territory in the past 10 years, which means the United States has now taken as many catastrophic typhoon and hurricane landfalls in a single decade as it absorbed across the previous 57 years combined. That is not a coincidence sitting quietly in a spreadsheet somewhere. That's a trend line, and it connects directly to the loop I opened earlier and still haven't closed: El Niño. Part 5: Why this season is different and why El Niño is the real story. Here's the mechanism in plain terms, because this is the part that actually explains everything you just watched happen. During El Niño years, the ocean's warmest surface water shifts east, away from Asia, out into the central Pacific. On the surface, that sounds like it should be safer for populated coastlines closer to Asia, except it isn't, and here's why. A storm that forms farther east has more open ocean ahead of it, more time, and more warm water to intensify across before it ever gets close to land. Meteorologists have a name for this exact setup. It's the textbook signature of an El Niño-driven super typhoon, and Bavi is essentially the model example, the storm you draw on a whiteboard to explain the pattern to a room full of students. The numbers back this up in a way that's hard to argue with. This is already the third Category 5 tropical cyclone globally in 2026, a year that isn't even half over. By mid-June, 12 tropical cyclones had already formed in the western Pacific alone, making this the most active start to a typhoon season by that point in the calendar since 1976, nearly 50 years ago. Every single month so far this year has produced at least one named storm somewhere in the basin, something that hasn't happened since 2015. The season's very first named storm formed on January 15th, the earliest start to a Pacific typhoon season since 2019. Now stack that against something most people don't expect, because it makes the whole picture click into place. Over in the Atlantic this same summer has been eerily quiet. No named storms threatening the U.S. Gulf Coast through the first half of July. A pattern experts are also tying directly back to El Niño, which tends to suppress Atlantic hurricane development through increased wind shear while simultaneously supercharging conditions across the Pacific Basin. Same global climate pattern, opposite outcomes, two different oceans in the same year. That contrast, not any single storm, is the real headline meteorologists are actually watching this year. It's not about one record-breaking typhoon. It's about where all of the planet's available storm energy is being funneled, and why. And Bavi isn't even operating in isolation this year. Earlier in the season, Super Typhoon Sinlaku became the season's first Category 5, followed not long after by Tropical Cyclone Horacio, which spun up over the remote South Indian Ocean with winds near 160 miles an hour, without ever threatening a populated coastline, a reminder that not every monster storm makes headlines, only the ones that find land. Bavi becoming the third Category 5 of the year means 2026 has already matched or exceeded what some full typhoon seasons produce from January to December, and forecasters are saying that with real concern in their voices, not just as a passing statistic buried in a research paper. When you have 3 storms reach the absolute top of the intensity scale before the season has even reached its historical peak months of August and September, that's not a coincidence anyone in the field is comfortable dismissing. Part 6: Putting Bavi next to history. Numbers like 180 miles an hour and 910 millibars tend to slide past people because most of us don't have an intuitive reference point for what those figures actually mean physically. So let's build one quickly using storms you might actually remember. Category 5 hurricanes that hit the continental United States. Storms like Andrew in 1992 or Michael in 2018 made landfall with sustained winds in the 155 to 165 mile an hour range. Bavi's peak winds over Rota were measured near 180. That's not a small gap. In terms of destructive force, wind damage doesn't scale in a straight line with speed, it scales close to the cube of wind speed, meaning a relatively modest jump in miles per hour translates into a dramatically larger jump in structural force hitting a building. A 20-mile-an-hour increase near the top of the scale can mean the difference between a roof losing shingles and a roof leaving the building entirely. Then there's the pressure reading. Central pressure is, in a lot of ways, a more honest measurement of a storm's raw intensity than wind speed, because wind speed estimates can vary between agencies and measurement techniques while pressure is measured directly. Bavi's 910 millibars puts it in the same range as some of the most intense landfalling tropical cyclones ever recorded anywhere on Earth, the kind of pressure reading that shows up in meteorology textbooks, not just news tickers. And remember, this happened at a point in the year when the Atlantic hadn't produced a single named storm yet. Bavi wasn't an outlier bolted onto a normal season. It was early evidence of exactly how abnormal this season already is. Part 7: What's already forming behind it. So where does that leave things right now as you're watching this? A new system, Tropical Storm Haitian, known locally in the Philippines as Josie, has already spun up in the same general stretch of ocean Bavi came from. As of the most recent advisories, it's a much weaker system, moving through unfavorable upper-level conditions that are expected to knock it back down to a tropical depression within days, and possibly dissolve into a weak low-pressure area shortly after that. It is not the next Bavi. I want to be clear about that, because overstating a weak storm to manufacture fear is exactly the kind of dramatizing this channel doesn't do. But it is proof the pipeline hasn't stopped. In an El Niño year like this one, the region doesn't get the recovery gap between systems that it would in a quieter season. Long-range seasonal forecasts, updated in the days immediately after Bavi's landfall, are still calling for an active back half of the year across the entire western Pacific basin, with warm water conditions expected to persist deep into the autumn months. That's the loop I want to leave open for you on purpose because it's genuinely true. Nobody, not the AI ensembles, not the national meteorological agencies with decades of data behind them, knows exactly which disturbance 3 or 4 weeks from now becomes the 4th Category 5 of the year. What we do know with real confidence is the ingredients aren't going anywhere. Deep warm water, low shear, an El Niño pattern actively steering storms into some of the most favorable formation zones on the planet. Those 3 conditions don't expire on a calendar. Part 8. The part that actually matters. Here's where I want to bring back that detail from earlier: 0 deaths on Guam and the Northern Marianas, despite winds that rivaled the strongest typhoon landfalls on record anywhere in the world. That wasn't an accident, and it isn't the part of the story that gets the most clicks, which is exactly why it deserves the last word instead of the first one. Evacuation orders went out early before the storm's full strength was even locked in by forecasters. Emergency shelters were staffed and stocked before the eyewall ever arrived. A population that has lived through Category 4 and Category 5 storms before knew exactly what gargantuan wind field meant in practical, physical terms, and they acted on that knowledge instead of waiting to see what happened for themselves. The uncomfortable truth buried underneath all of these record-breaking numbers isn't really about wind speed or ocean temperature, or even El Niño on its own. It's about lead time. Bavi went from a tropical storm to a super typhoon in roughly 48 hours. That is an incredibly short window for any coastal population anywhere to prepare in, evacuate through, and secure everything that needs securing. The only reason this didn't turn into a mass casualty event in the Marianas is that warning systems, built and funded years in advance of this exact scenario, gave people that narrow window before the storm arrived instead of after it had already hit. That's the pattern genuinely worth watching as this El Niño year keeps producing storms like this one. Month after month, it's not really a question of whether the Pacific keeps generating monsters, because the data already answers that it will. The real harder question, the one meteorologists are actually losing sleep over, is whether every place in these storms' future paths has the same warning infrastructure Guam and the Northern Marianas had, or whether the next gargantuan storm forming somewhere out over that same warm stretch of ocean right now finds a coastline that doesn't. If this kind of breakdown is what you come here for, the mechanics behind the headline, not just the headline itself, subscribe, because I track every one of these systems from the moment they form to the moment they make landfall, and the next one is already spinning up as we speak. Drop your answer in the comments. Have you ever had to evacuate or ride one of these storms out yourself? I read every single one of them, and honestly, those personal stories are usually where the most useful information in the comment section actually lives. Let's get this one to 5,000 likes so the algorithm actually puts it in front of the people living in these storm corridors who genuinely need to see it before the next system spins up. One more thing before you go, because I think it's the single most useful takeaway buried in all of this. If you live anywhere along a Pacific Gulf or Atlantic coastline, the lesson from Bavi isn't watch the news more closely. It's know your evacuation zone before the forecast turns urgent. Guam's population survived a 180-mile-an-hour eye wall not because they reacted fast once the storm arrived, but because the decision to leave had already been made days earlier while the storm was still just a set of forecast cones and probability percentages on a screen. That's the entire difference between a headline about damage and a headline about casualties, and it's decided long before the wind ever picks up. Thanks for watching. I'll see you in the next one.